Hello, pre-calc friends. So we're coming to the end now of section 6.6. As we said, it's a pretty long chapter. We look at all these different examples that we've had, and they're going pretty well. But as it went more and more forward, they got more and more challenging. So again, my clue for you is just take really good notes. Remember how we've been putting examples on the left-hand side, and then all these words and suggestions and hints on the right-hand side? Keep that up, because these last four are going to be the most challenging. As you can see here, getting more difficult. So this is the end of 6.6 and the end of chapter 6 finally. So number 11. This one says we want to solve, and it looks like this. 2 sine squared of theta minus 1 equals 0. Over here it just means we're going to be in degree mode and we're in one circle, no negatives. All right, well, you know, sometimes I think of trig like algebra, so maybe it's easier to think of it like this. Instead of 2 sine squared minus 1, I'm just going to write 2x squared minus 1 equals 0. And I think to myself, how do I solve that? How do I solve for x? And really, you just try to isolate the x. So my clue for you over here, guys, is why don't you just go ahead and isolate the trig. Try to get the sine by itself so that you can solve for theta. So that's what I'm going to do over here first. Let's try to get the sine by itself. So the first thing I'm going to do is going to add the 1. So I get 2 sine squared of theta equals positive 1. Next step, do you see, we're going to divide by 2 on both sides. And I get sine squared of theta equals 1/2. And normally if that squared wasn't there, this would be pretty easy. We could find where the sine equals 1/2 pretty easily. But it is a squared, so we have to do the square root on both sides. And now I get the sine of theta equals the square root of 1 over 2. But I missed something. Did you catch my mistake? And it's a big one here, so make a note off to the side if you missed my mistake. Yes, ma'am. Yes, sir. So don't forget the plus or minus. When you're taking the square root here, friends, don't forget the plus or minus. So maybe put that as a note off to the side. You have plus or minus. So you have two different answers. Now, first of all, I'm not a big fan of that square root of 1 over 2. So can I do maybe this? That's legal because it's a fraction. And the square root of 1 is just 1. Great. Which is the same thing as, if I go up here, the same thing as root 2 over 2 if I rationalize. And I did that because I know what that is. I know root 2 over 2. Those are usually the pi over 4s, right? But here's the problem, the plus or minus. So if I go back down over here, because it's plus or minus, I really have two different paths here I need to solve. Either the sine of theta equals the positive root 2 over 2. We'll find those answers. Or the sine of theta equals the negative root 2 over 2. We'll find those answers. And again, this is not terribly difficult. It's just more to find, right? So again, a big circle up here on that plus or minus. Please don't forget. And the reason is because you took the square root of both sides, so you got two answers with a plus or minus. Okay, look around your unit circle, folks, and where is sine equal to root 2 over 2? I found it's equal to root 2 over 2 at 45 degrees. And also, again, in the second quadrant at 135 degrees. That one is done. Now move over here to the right side. Where is it equal to negative root 2 over 2? And that's actually the other quadrants and the other pi over 4s. So I would say 225 and 315. And that's my final answer to problem number 11. So again, to recap on number 11, the trick here was to isolate the trig. It's only one single trig here. It's just sine, really. So try to isolate it. We thought about it like it's algebra. So isolate the x or isolate the trig. When you took the square root, don't forget about the plus or minus. And then that broke us into two different equations that we had to solve for, and then it was just all unit circle. And that's number 11. All right. Before we go on to number 12, I'm going to take a little break and go back to Algebra 2. This is why you guys were working so hard on the factoring the other day. Can you solve this for me really quick? Factor and solve. Pause right now, go and solve it, and come back. Okay, this one factors actually pretty nicely. Of x minus 4 and x plus 1. And once we factor it, we're not done because we need to solve. Remember, if these multiply to give you 0, either this friend equals 0 and we'll solve it, or this friend equals 0 and we'll solve it. Therefore, final answer here, x is equal to positive 4 and negative 1. Okay, that's the answer to that. That's great. The reason I'm preparing you for that is because now let's go back to trig land and do the exact same thing. Number 12 says, can you solve cosine squared minus 3 cosine minus 4 equals 0? Folks, do you agree that this answer here is actually the exact same kind of question as right up here? These guys are pretty much linked together. Why? Because it's a cosine squared minus 3 times a cosine, and then minus just a number. So do you recognize that this is a quadratic? And that's really important. So maybe put that in your notes off to the side, that this is a quadratic. And you're going to solve it the same way. If it helps to rewrite it like this with x's instead of coses, go for it, guys. Go ahead and solve it like that and then bring the cosine back. But this is what I think of this. This is a cosine squared and a cosine and a leftover number, so I think he's going to be a quadratic here. All right, let's bring him on down here. Let's go and solve him. So because he's a quadratic, we can go ahead and try to factor him like this. All right, but instead of x minus 4 and x plus 1, the thing that's being squared here is the cosine. So it's really cosine of theta minus 4 and cosine of theta plus 1. And if you actually tried to FOIL that back out, you actually would get this guy that you started with up above. So this is right. This is fully factored. Nice job. So off to the side, if you want to write factor, that helps a lot too. All right, well, like before, if these multiply to give you 0, either this friend equals 0 or this friend equals 0. Let's see what we get. That means cosine of theta minus 4 equals 0, or the cosine of theta plus 1 equals 0. Okay, on the right-hand side, let's deal with him first. How about the cosine of theta equals minus 1? And you think about where does that happen? Where is the cosine equal to negative 1? And that happens only at pi or 180 degrees. And nowhere else. It's one of the few questions where there's only one answer to that. Fine. Now, I'm a little worried over here. Let's see. Where's the cosine of theta equal to 4? That's a weird number. Well, that's a very weird number, in fact, and it's not on our unit circle. So we can try to take the inverse if we want. Try to put that in the calculator and see what you get. Okay, while you're doing that, I'm going to go off to the side here for a second and just ruminate on something. Ignore number 14, but I'm just going to draw some stuff up here. Don't mind me. Do you recognize that curve? And do you recognize that curve? Yeah, this is the sine curve, and this is the cosine curve. Do you remember when we first graphed these? It went up to an amplitude of 1 and went down to its negative amplitude of negative 1. And same thing with the cosines, up at 1 and down to negative 1. Do you guys notice that it never goes any higher than 1? It never goes any lower than negative 1. Same thing up here for cos. It never goes any higher than 1 and never lower than negative 1. Which means the sine curve is actually completely bounded by negative 1 and 1, and the same thing with the cosine. So what I'm trying to tell you is that the sine and the cosine curves are always going to be between 1 and negative 1. Cosine will never be bigger than 1 or less than negative 1, and the sine as well. Why don't you put this off to the side, and I'll explain why this is really important. So again, the sine curve and the cosine curve is always less than 1 and greater than negative 1. It'll never be greater than 1 or less than negative 1. Okay, here's why. Now, can we go back down to the bottom of this problem? Look what you found right here, guys. You found the cosine equals 4? Well, 4 is greater than 1, and we just said on the previous screen that cosine will never be greater than 1. So if you see this, from now on, instead of even doing this step here, you could just take that step and just cross it out, because you know that doesn't exist. That's a D and E. It does not exist. So we don't have to solve that one. anytime you get to this kind of point where you get an answer where the cosine or the sine is greater than 1 or less than -1, it doesn't exist. It just doesn't happen, so you can cross it out. So that part of the problem doesn't work. The only answer to this entire problem is this one here. And that's number 12. I'm going to pause, and we're going to finish up number 13 and 14 together.